Hello. Okay, so today we are live streaming pre-calculus questions so that we're ready for calculus pretty soon. If you have any questions about real, type them in the chat, tell them. So, first question we have. So, the first thing we're going to do is we're going to review functions. So, we have a function, we have a graph of a function here, and we're going to try and find some values and properties of the function using the graph. So, first thing is find f of t. Brush f of 2 So f of 2, we're going to find value of our function. Our 2-line. So inside of our function is the horizontal distance travel, and value that comes out of the function is vertical distance. So we move over 2, go up until we hit the function, we get a value of 1. Plug 2 into the function, go until we hit the function, up or down. Okay, estimate f of a half. So we're going to go over a half. Go over a half. Go over a half. Go down. Get to this height here. Figure out, well, what is that height? So this is going down 1 to here. About a half. A little bit less than that. So depending on how good we think our estimation skills are, say 3. I'd say that that's about closest we're gonna get without maybe counting pixels hard like that. For what values of x f of x equals 0. Well, we have to figure out, this is the other way around. From what we did here was we plugged in the numbers that are inside and turned those into a horizontal motion. Here we have a number and it's outside our function. So we're going to do a vertical motion to figure out. Instead of plugging in a number and getting out a number from our function, plugging in a number representing horizontal distance, getting out a number that represents vertical distance, we're going to move up and down our graph. That represents the output of our function. And then looking at the horizontal coordinate corresponding to that point, give us our input that led to our. So here we have what values of x is makes f of x 0. Well, we want to look at 0 vertical line. So this line here is the x-axis. It represents traveling no vertical distance. See that we intersect the graph at 3 points. These are at y equals 0, y equals 1, y equals negative. So for what values of x, f of x equals 0, get x equals. You get x 1. So estimate the value of x such that f of x 1. So we're going to look at negative 1, the line y equals negative 1. That means that we traveled a vertical distance of 1 down from the origin. And this is the point where that line crosses the graph. And we have to figure out now, what is the distance between that point and the origin? So traveled at least 1, a little bit more than a half. Say 0.6 there to there. So it'll be x negative 1.6. Okay. So state the domain and range of f. Okay, so we have to recall what domain and range are. Domain and are. So the domain are all valid inputs for our function. Our function is graphed over this horizontal region. This goes from x is negative 2 all the way up to x equals positive 2. This is going to be our domain. On the other hand, our range image are all of the possible output. So we hit everything from negative 2, y equals negative 2, all the way up to y equals 1 in our range or our image. So range is actually a term that's not used much in mathematics. Usually the term used is image. Range is kind of the term that's used for high school level mathematics. Image is the one that's more commonly if you go further. Domain has no reverse about it. Although in this class we'll probably use the term range. Just know if you're a math major, eventually you'll have to start using it because that's the more common one. Okay, so let's look at our next problem. drawing there. Anyway, sketch a rough graph of the temperature of a meal that's been cooked, refrigerated, and then reheated over time. So, starting at time equal, well, let's say that time that we cooked over here. Make this longer. Okay, so we'll say that the time that the meal was cooked is time 0. That's when we start recording the temperature. So we're going to start cooking at the line, at the y-axis. Well, what's going to happen is whatever the temperature is, it's going to start at some temperature, and it's going to go up gradually. Well, it's going to change temperature fastest and gradually slow down until it reaches basically the temperature of the pan. Then, after it's been cooked, you know, it'll gradually cool off. It'll cool off fastest the moment it's taken off the pan, but over time, the rate at which at which it cools off will decrease. Hard draw. Eventually, it's back down to around room temperature, at which point it gets thrown into the refrigerator, at which point it will pour. Probably won't freeze. Most refrigerators are around 34 to like 30 Fahrenheit. I'll be like 1 to 3 degrees Celsius. And then the thing is going to be taken out and reheated. We're going to assume that doesn't take long to go from the fridge to the pan again. So it'll heat up, and then the rate at which it will slow down over. There we go. So this region is it being cooked. Region is being eaten. Region is refrigerating leftovers. And then from here to here is it being okay. So that's how to do those types of problems. Move on to our next problem. Okay, so go. We're going to evaluate this piecewise function. So the way that we handle piecewise functions, they look pretty scary, but they're not really all that bad. So, for example, if we're doing f of -2, well, first we have to figure out which chunk has x equal -2. Well, -2 is less than 1, so it's this chunk. So we're going to plug -2 in for x function. This line here means that we're going to plug something in to the expression that it's so x equals -2 gets plugged into this expression that x. So we get 2 for x plus 1, which is just -1. So our answer is -1. Do the same thing with our other problem. Get f of 0, well, is 0 less than 1? It is. So that means that we get x plus 1 with x 0 plugged into it. We get 0 plus 1, which is 1. And that is our answer for part 2. Then part 3, we get f of 1. Well, 1 is not less than 1, so this is not the chunk that we... So, otherwise just means if it didn't fit into any of the other chunks, it fits into the... So, we plug x equals 1 into this chunk, x over 2, gives us 1 over 2, which is already the form that we can accept. So these aren't so hard. Piecewise functions look harder than they are. But that's all we have to do for that. Okay, so let us look at another problem. We want to give a function for this curve. Okay, so it looks like we have a line and another line. We might be able to do this with some strange looking equation. It would have to be a very strange looking equation. It'd probably do... Oh, put a link to this video to a video explaining Fourier transform. Find an equation for... However, there are much simpler ways of doing it if we just allow ourselves to use piecewise function. So we're going to set up our piecewise function. Like we'll have two cases. One is the case in here, and the other is in the case in there. So we'll have, let's have our first case be, usually it's easier to handle positive stuff. Go x equals, go 0 is less than or equal to x is less than. Now we have to figure out, well, what would be a nice equation to define this chunk of the graph? Well, this looks like a line, so let's find a line that looks like this. Line has an intercept of 2 and a slope of -1. So, fortunately, we know a slope-intercept form. Slope times our variable plus our intercept. That is this chunk of our graph. So, next thing to do, look at the other chunk of the graph. This is the chunk from -1 is less than or equal to x is less than or equal to 0. So that gives us -1 up to 0. And it looks like a line as well. Like the intercept is still 2. Slope here, it goes over 1 and up 2. So this is going to be a slope of 2 times our variable plus our intercept. And this is our completed function for this curve. Okay, that's not so bad. Let's look at another problem. Okay, so the problem that we have in the book, this one, says function has domain -5 to 5. A portion of its graph is shown. Graph of f if f is even. Complete the graph of f if f is even. So, here's the graph. Graph here. Now, we're not going to do this exact problem because we want to leave that for you to do. But we'll do something similar. So, first of all, what does it mean for a function to be even or odd? Know what it means for a number to be even or odd. So a number n is even if remainder dividing by 2 is 0. And odd if the remainder is 1. Okay, so we recall that, but that's not what we're doing now. We want to know about function. So let's there we go. Okay, so here's the definition. F is an even function if f of x equals f negative x for all x. Odd. F is odd function if negative f of negative x equals f of x for all x. Okay, so let's give an example of the first one. So f of x equals x squared plus 2 is even. How do we check that? Well, the definition was f of x negative, or f of negative x for all x. Let's see what happens when we plug in negative x for this function. F of negative x equals, well, you just take the thing that's inside of the function and you plug it in wherever you see an x. So we get negative x squared plus 2, but negative signs in an even root, an even exponent will cancel. So x squared plus 2. Hey, look, this same as that. Well, if f equals this equals this, this equals this, that means that this equals this. So that means that f of x equals f of negative x. And since we didn't actually pick a value for x, this works for all x's. That satisfies the definition for all x. Okay, so that's our example of an even function. Let's look at odd function. So the definition was negative f of negative x equals f of x for all x. So let's find an example of this. Let's say f of x equals x cubed plus let's do 4x. There we go. So with this one, what we do is we're going to write negative f of negative x, which means that we get negative x cubed plus 4 negative x parentheses. So these negative x's are because we plugged this into each of our x's in the function. This negative comes from that negative outside of the function. So let's simplify. Well, negative x times negative x, the negatives cancel, and then times negative x again, the negative comes back. So we're going to get negative x cubed, and then 4 times negative x is negative 4x, and then we're going to distribute this negative sign over. Negative times the negative is positive, negative times the negative is positive, so we get x cubed plus 4x. And this is that. So since f equals this, equals this, equals this, equals this, equals that, these two things are equal to each other. And since we didn't plug in a specific value of x, they're equal for all x. So f of x equals negative f of x for all x. This is an odd function. Okay. So first of all, we've shown that there is at least one even function. We've shown that there's at least one odd function. But can a function be both even and odd? Or let's check this function. This odd function here, is it also an even function? So let's do that. Have the definition of an even function was f of x equals negative f of x, or f of negative x. Let's check this, see if this works. We're going to need some space. So f of negative x equals negative x cubed plus 4 times negative x. And then what? Well, cubing the negative x gives us negative x cubed. 4 times negative x is negative 4x. This looks very similar to our original function, except that our original function is positive. This one is exactly the opposite. So this function had positive coefficients. These have the negatives of those positive coefficients. So they're exactly opposite sign. So this function here, we showed it is odd, but it is not even. So that means that we know that there are even functions, we know that there are odd functions, and we know that at least some functions that are even, or some functions that are odd are not even. Well, let's look at our other function. We had it was x squared plus 2. We're going to try seeing if it's odd. This is using the old function f of x squared plus 2. So negative f of negative x equals negative x squared plus 2. This negative x here, it goes in everywhere we see an x, and the negative on the outside stays on the outside. Okay. So, simplifying, we get the negative cancels in here. This negative, do it one step at a time. So just like how our odd function wasn't even, this even function is not odd because these two things are not equal to each other. So the question is, are there any functions that are both even and well, I'm leaving that you guys to think about, and usually make this an extra credit question class. So you are wanting to get ahead a little bit, that one a little. So let's write down the question formally is prove or to find a function that is both even and odd, or prove that no such function exists. There. This is a problem for you. Okay, so let us onward to at least one more problem. Get a new sheet. Okay. Match each equation to its graph. Don't use a computer or a graphing calculator. Those ones we'll skip. I mean, you guys won't. Got problems for the next section. Okay. Find the domains of the functions g, g of f of f, and g of g, and their domain. So we'll do this, and we'll make up our own function. The problem that we were given to do for homework was 36. We'll make up our own. Okay. So let's pick an f of x equals. Let's do x plus 1 over 2x minus 3, and g of x equals, let's do 2x minus 1. Here are our two functions. Do f of g of x. So everywhere where we see an x, in f, we're going to plug all of g into it. So we're going to get 2x minus 1 plus 1 on the top, and 2 times 2x minus 1 minus 3 on the bottom. And we'll simplify, even though this here, the completely valid way to describe f of g, we're going to simplify just because we can. It's not difficult. So we get 2x on the top, because this negative 1 and that positive 1 cancel. And we'll get 4x. 2 times negative 1 is negative 2. Minus 3 gives us 5. This is f of g. Next one is g of f. That's going to be 2 times. We just plug in the other way around. All of f goes into g. All of this. There. Okay. So 2 times x plus 1 over 2x minus 3 minus 1, which is equal to 2x plus 2 over 2x minus 3 minus 1. And for the sake of practice, we will combine fractions. Get 2x plus 2 minus, so what we're going to do is multiply this by 2x minus 3 over 2x minus 3. 1 times that, because that'll get us a common denominator. We can combine like fractions, so we get negative 1 times 2x minus top. Negative 1 times 2x. Bottom, we get our common denominator of 2x minus 3, which simplifies to 2x minus 2x is 0x on the top. And 2 minus negative 3 is the same as 2 plus 3 is 5 over this is g of f. X. Okay, and we wanted f of f. This is sometimes written as f of f of f. Or like this one here could have been written g of f of x. Be familiar with this notation. It does come up in the class. Oh, so all this circle means here is that this function, the outside function, this function is the inside function. For time, we'll f of x is f of g x, and that's all we have to do. Okay, so going on, f of x. Well, everywhere that we see an x, we plug in all of f. So f was this fraction. We had, if you recall, x is here. We're going to put all of f in this location. So we get x plus 1 over 2x 3. That x got replaced with all of f. We have plus 1. Denominator, we get 2 times all of f, which is plus 1, x minus 3, and then minus 2x minus 3, but x has been replaced with all of f. Then, this one is a bit more complicated to simplify, but it is good algebra practice. So, let us simplify this. We have to find a common denominator between this function, this expression and this expression. We can combine the fractions on the top. That's 2x minus 3. So, what we get is x plus 1, that's this part, plus 1 times 2x minus 3 over 2x minus 3. That's the top fraction. Bottom fraction, we still multiplied by this 2x minus 3, so we get 2 times x plus 1 minus 3 times 2x minus all over 2x minus 3. This fraction over this fraction we have now. But dividing by a fraction is the same as multiplying by its reciprocal. So that means is we come down here, it's the same as x plus 1 plus, well, 1 times 2x minus 3 is just 2x minus 3, 1 times anything, over 2x minus 3. That's our top fraction. And then we're dividing by this other fraction, same as multiplying by its reciprocal. 2x minus 3 is the denominator. Reciprocal just means flip the fraction over. So dividing by this fraction like this, same as flipping this fraction over and multiplying by it. So the denominator is up here, the numerator is down here. 2 times x plus 1 minus 3 times 2x minus 3. Now, if you're wondering why I'm not simplifying these fractions, you know, like combining maybe this x with x or anything like that, you totally could. In fact, I would probably do several of these steps simultaneously if I were calculating something myself. But because I'm trying to do an algebra, I'm doing one technique at a time. So if you're worried about having to write each of these steps out individually for your homework, you don't have to worry about that. Write out, you know, enough steps that the grader will know where you're going, but you can probably combine 2 or 3 or 4 steps together in little algebra manipulations, and the grader will be able to follow you. Anyway, so that will cancel with that. And we get, now we're going to combine, I'm going to combine x and 2x is 3x. 1 and negative 3 is negative 2. 2 times x is 2, minus 3 times 2. This is a negative 6x, a positive 2x, so that's going to be a negative 4x. Get 2 here, and negative 3, so that's negative 3 times negative 3 is 9, plus 2 is 11. Get here is f of x. Okay. Scroll down a bit more. We want g of x. That's g of x. Well, what was that g in the first place? G was 2x minus 1. This will seem like absolute cake. 2x minus 1. Right? X minus 1. Everywhere we see an x here, namely here, plug in all of g in that. So plug 2x minus 1 there. Get 2 times 2x minus 1. 1. We'll simplify. So 2 times 2 for x. 1, 2, 1, 4x minus 3. And this here is g of x. Okay. So we now have been going for minutes or so, give or take. And we will leave more calculus problems done in a future live stream. So when the semester starts, I'll get into a regular schedule of these. I'm planning on having 1 or 2 next week. I won't be able to do any the week immediately before the semester starts, so we'll try and get 2 more live streams in next week and then we'll set up a regular schedule once the semester starts. Okay, so I will see you all when the semester starts. Good luck on your homework. If you have any questions, please email me and I will answer your questions. And all do well in calculus. Bye.